Okay, so in last lecture, we have talked about expectation or expected value, and let's review a bit, right? Expected value. So when we toss a die, right? When we roll a dice, the X, right? The dice can get the value 1, 2, 3, 4, 5, 6, and the corresponding probability, right, is 6/1, right? It's always 6/1 for every value, right? For every value. Okay. So yeah, so this is a case, and it's all 1/6, and so we can calculate the expected value of the dice or the expected value of X because X can take value. X can take value 1, take value 2, take value 3, can take a value of 6, right? So then it's 1 times, it is always value times its corresponding probability plus value times its corresponding probability plus dot 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 plus value times its corresponding probability. And this is 21/6, which is 3.5. I mean, you can just write it 21/6 or 7/2, right? Okay. So in yesterday's lecture, we also gave a definition of what is a variance. So variance is just you sum together, right? You use like one, right? You use x1 or you use each value of x, right? Use each value of x and minus is the expected value, right? And you sum this over, sum over, right? You sum over x, sum all this stuff, right? X minus its expected value and squared, right? So after you sum all of them together, you divide it by 6, right? So if we write this in concrete numbers, in specific numbers, it's just 1 minus EX. EX is just 3.5, right? So 1 minus 3.5 and squared. And I think some of you may have a calculator, or you can just calculate by hand. Yeah, so either way. So we sum them all together, right? And remember that after we sum all the square, right? Sum all the square. And yesterday we have talked about the y-weight square, right? So remember, for variance, y-weight square it, right? Y-weight square, so we have already explained this. And also y divided by 6, right? Y divided by n, right? N is a number of values it has. Okay, so in previous lecture, we have explained both these two questions. And then today, so we are going to calculate this, right? So I want like you to actually calculate this. So this should be a number. And if you don't have a calculator, use your hand. If you have a calculator, you can use calculator to calculate this. Yeah, I will pause the video a bit, pause the recording a bit, and give you like 5 minutes to get the number. So try to calculate this. It is quite important because we'll calculate a lot of stuff, and I eventually want you to see connections between numbers. Maybe Emma, do you have an answer for this?
Is it like 35 over 12, which is also like 2.9?
Okay, 35/12 is correct. Yeah. And yeah, I mean, let's actually calculate this together. So I really doubt that we need a calculator for this, right? So for this, it's just you see 1.3, 1 minus 3.5 is just 2.5 because I mean, although it is negative, but you can ignore the negative sign because you square it, right? So it's just 2.5 square, right? 2.5 square is like 25/4, right? 25/4 plus. Then it's 2 minus 3.5, which is 1.5, 1.5. So negative 1.5 and 1.5 square, right, is 3/2 square, which is 9/4, right? 9/4. And then again, we have a 3 minus 3.5, which is 0.5, right? And that square is just 1/4, and everyone knows that. And the other three is just symmetric, right? It's just symmetric number, so we can do something like this. So I really doubt that we even need a calculator for this. Yeah. So, and then overall we divide by 6, right? And we just need to calculate. So everyone is divided by 4. And actually, so we can just ignore this, right? So, I mean, to calculate this, we can ignore half of them because this is repeated. So we can just use this times 2, right? This times 2, what is that? That is just Because everything is over 4, so you can make them over 2 because you times 2, you multiply 2, right? So 9 over 2 plus 1 over 2 over 6, right? So I mean 25. So 9 plus 1 is 10. 10 plus 25 is 35. 35 over 2 and then over 6 is 35 over 12, right? Yeah. So yeah, next time I'll give you more time to actually calculate the number. Yes, 35 over 12. This is very correct. Okay, so now let's calculate something else. So let's calculate EX squared. But before we calculate the EX squared, so you see the definition of EX is this, right? So it's like the value of X times its probability. So can someone tell me what is EX squared? Like don't give me the answer, but give me like the expression or using some words, right? Using words, natural language to describe what is EX squared compared to EX. Maybe Amash, do you know what is EX squared? I mean, E
Uh,
expected value, right? Yeah. So what does this mean?
uh, the expected value squared is
Actually, it's not expected value squared. So think of EX. What is EX? It's average value for X. Is that correct?
yeah.
Yeah. So then what is EX squared? It is the average value of X squared, right? Then how to calculate the average value of X squared? How do we do that?
Use EX squared.
Yeah, I mean, how do we calculate it? So we just find each value of x squared, right? Find each value of x squared, and times its corresponding probability. Do you agree with that?
Yeah.
Okay, so then give me the expression. So what is the first term?
Uh, 1 times
1 times
1
what?
over 30, 1 over 36.
What is the probability of x squared being 1? What is its probability? Is it 30? It is 1 over 36? I mean,
Uh,
x squared being 1 is just probability is 1 over 6, right?
yeah.
So you tell me it's a corresponding probability. You don't tell me probability squared. You see, you still didn't understand the idea. The idea is that this is the average value of x squared, right? How many number of values can x squared take? It can only take 6 value, right?
Yeah.
So then tell me. So let's start this all over again. So what could be a value of x squared? Give me all the values. Yeah. So what could be a value of x squared? I mean, x can be the value 1, 2, 3, 4, 5, 6, right? So what could be the value of x squared?
Um,
I mean, if I'm 1, x squared is 1, right? This is one value. And what's the other value? I mean, you have x. Now give me a value of x squared. You know how to
36.
square, right? So x can be 1. So x squared can be also 1. What if x is 2? What's the value of x squared?
4.
Yeah, 4. And what could be some other value of x squared? 1.
Oh,
And,
uh,
and then what?
9.
Yeah, of course. Yeah, and then what? 16, right? And then what?
Yeah. 25.
Yeah, you see, so it is a simple question. So x can be only the value 1, 2, 3, 4, 5, 6. And x squared can also only be these 6 numbers, right? It cannot be 20, right? So whose square is 20? I mean, that's not among x, right? So of course, being 20, x squared being 20 has probability 0 because it can never be 20, right? And then you need to continue to answer this question. So what is the probability of x squared being 1? What is its probability?
1 over 6.
And the y side?
Because there are 6 values. And, like,
Yeah, I get your point. You're right. but you should not answer. You should not use that as our argument. Why? Because if I have six values, that doesn't mean I'm a 1/6, because then each value needs to appear with equal probability. Then that will make it 1/6, right? So
Yeah.
the only way you can say that x squared equals 1 is has probability 1/6, because the only way for x squared to be 1 is for x to be 1, right? And we already know that for x to be 1, it has probability 1/6, right? So then the probability of x squared being 1 is 1/6. And also, it's the same applies for 16, right? Why? Because the only way for x squared to be 16 is for x to be 4, right? I mean, if x is 3, x is 5, it cannot be, its squared cannot be 16. So the only way for x squared to be 16 is for x to be 4. And what is the probability that x equals 4? The probability we already know is 1/6. So the probability of x squared being 16 is also 1/6. Yeah. Okay. So now I want each of you to calculate what is ex squared, right? Remember, use each value to time its corresponding probability and then sum them up, right? Because you know all these values could appear, and each appear with a certain probability. So each value times its corresponding probability and add them up. That is the average score of x squared, or that is the expected value of x squared. I will give you another 2 minutes to calculate the answer. Yeah. Okay, so does anyone has an answer for that? So maybe Jason, can you give us the answer for this?
It should be like 1 times 1 plus 4 times 1 6 all the way to
Yeah,
6. No, 36 times 1 6,
yeah,
which should be equal to 91/6.
91/6. Correct. Yeah, that's very good. So now we have calculated. So we have calculated two things, right? One is the so this is called the variance of x, right? So in the same setting, we know that variance of x is equals to 35/12, and ex squared equals 91/6. And I want you to calculate another stuff. And yeah, and also we know ex is 3.5, right? So ex is equal to 7/2. Yeah, so I want each of you to calculate this. What is the value of x squared minus ex squared? Yeah, you see, you already have the value here. You also already have the value here. Try to calculate this, and this should not be that hard because you are only scoring a very small stuff. Yeah, try to calculate this and give me the answer. So you can give me like in fractional number, right? Don't numerical number. We need a fractional number. I'll give you another 1 minute. So this is simple. So only 1 minute to do this. Okay, maybe Hector, can you give us a number for this? What is the ex squared minus ex then squared?
35/12.
Very good. It's 35/12. So we found that this is exactly variance of x, right? Yeah. So, I mean, I could give a, so this is a very important formula for all of you to memorize. And I mean, we have verified it with with this example, right? And of course, we can give a formal mathematical proof why this is true, but I won't bother you on this. I mean, if even if I give the proof, a lot of you may only understand a partial of it. Yeah. So, but you can do memorize this formula because you see, when you calculate variance of x using this way, right? Using this way, you need to calculate a lot of stuff and square them and sum them together. Yeah. But calculating this maybe like maybe easier. I mean, only tiny easier, right? Because calculating this involves calculating both this and I mean this is easy, but this also needs some calculation. Yeah. Nevertheless, this is a formula and you could use it. Okay, so let's try practicing some more. Um, let's see. Let's try to practice some more stuff. So what is for example, say we roll two dice, right? We roll two dice. So roll one dice, right? Roll a dice. Roll a dice x1, right? X1 can have value 1, 2, 3, 4, 5, 6. And we roll another dice, right? Another dice x2, which can have value 1, 2, 3, 4, 5, 6 as well, right? And these two dice are independent, meaning even if I roll a 3 here, I still have equal probability of rolling a 6, 5, 4, 3, or 2, or 1 on the second dice. Okay. Now I want you to calculate two things. What is the expected value, right, of the sum of these two dice? And then what is the variance of this sum, right? Yeah. I want you to calculate this this two this two stuff. Yeah, I mean this is easy, and this you may need a bit of thought. So when you are not sure, try to see how we calculate variance here, right? Yeah, I mean x1 and x2. Yeah, this is actually your job. You can think so you can use this way. Think what could be x1 plus x2. I mean, of course, it can be 2. It can also be 3, right? So for 2 is 1 plus 1. For 3 is 1 plus 2. And for 4, it could be either 2 plus 2 or 1 plus 3 or 3 plus 1, right? So so in this case, it's the probability of x1 plus x2 being 2 and being 3 equal probability. Maybe maybe Mark, can you answer this question? So do you think it is equal probability that x1 that's the sum being 2 or being 3?
I don't wait.
I mean, what's the probability of x1? So what is the probability of x1 and x2 when they sum to 2? What is the probability of this? You can actually calculate this.
Um, 1/6. Wait, no, 1/36.
And why and why?
Because like wait, I don't know how to explain this, but in math class in our school we just like drew a table which we just like we just count how many squares we had in the table and like 6
Okay.
times 6 is like
Yeah,
36.
yeah. It's a like a denominator, right? For the numerator, you count the number of squares on there, right? Okay.
Yeah.
I get what you want to express, but I mean it can be put in a more simple way. It's just that in order for this sum to be 2, the first dice need to be 1, and the second dice also need to be 1. What's the probability of the first dice being 1? It's 1/6. What's the probability of the second dice being 1? It's 1/6. And for this to happen simultaneously, it is 1/6. So let's write it this way. So before we even calculate the stuff, the two value below, let's calculate the probability of 2, right? When I say 2, I mean x1 plus x2 equals to 2, right? Okay, so probability of this is that I mean x1 and x2 must always be 1, which both have a 1/6 probability. So this is a 1/36. And maybe like Hector, can you give us the probability that x1 and x2 what's the probability that they sum up to 3?
2/36.
Very good, because it can either be like 1, 2, or 2, 1, right? So it's 2
Yeah.
over 36. Very good. And I give you like, so I want each of you to calculate everything. So by everything, I mean, maybe Hector, can you tell us what's the maximum that x1 and x2 can get? What's the maximum sum?
12.
Yeah, 12. Cool. So we already get like 2 and 3, and I want each of you to calculate everything. So from 2, 3, this is 4, and then 5, yeah, and then 5, and then 6, and then 7, yeah. I will give you 5 minutes. Yeah. So this course is really about practicing how to calculate probability, and so that we can understand through our calculation. Because in previous lectures, I try to be more focused on the theory side and on the concept. But I think like if we are too focused on the theory, then we are difficult understanding understand it, right? Because when you really calculate it by hand, you could get a more concrete idea of what's going on. Yeah. So for all this, I want each one of you to calculate everything, and then we will check the answers in 5 minutes. Yeah, try to calculate this. I mean, if you are really quick, right? If you are really quick at the calculation and you found, oh, I already found out all this probability, then you can go ahead on calculating this expected value. Remember, expected value is nothing more than you see each value times its corresponding probability, right? You have all the corresponding probability and you have the value here, right? The value here is 2, 3, 4, 5, 6. So you can go on calculating this and go on calculating this if you are really quick. But if not, then I will go 5 minutes, and then that should be enough for you to calculate all this stuff. You can use whatever method you are most comfortable with. Yeah. So resume recording. Maybe Emma, you can you give us the answer for this one
3/36.
and the reason?
Because there's like three possibilities, which is like 1, 3, 2, 2, and 3, 1.
Very good, very good. Yeah. So you can say that there are like 3 cases. Yeah. So it's 3/36, right? Yeah, and we don't need to further simplify this because it is good to make the denominator all 36. Yeah, and maybe I'm sure what was the answer for this?
Uh, 4/36.
And please give all the 4 cases.
Um, the four cases should be I think oh 1 and 4 and 2 and 3, 3 and 4, 3 and 2 and 4 and 1.
Very good, very good. That's very good. So 4/36. And Mark, can you give us the answer for this?
5/36.
Yeah, so we sort of already found the pattern, right? Yeah. So 1, 2, 3, 4, 5. So then what's Jason? So what's the answer for this?
It should be 1/6.
Yeah, 6/36, so 1/6. So let's continue. So what was the answer for this, Jason? So for 8.
Oh, this one should be 5/36.
Very good. You see, so when it gets higher, right? When the sum gets higher, the probability decrease. So it means that it is equally rare, right? So it is equally rare for you for you to sum up a really small one and sum up for a really large one, right? I mean, for the middle one, it is like quite common. And maybe Hector, what's the answer for this? For when it sum up to 9?
9, it's 4/36.
Very good. Yeah. You see, we found the pattern and it's just it's symmetric, right? So it decreases like that. And maybe Phoebe can give us the answer for this. This 36. Yeah.
3/36.
Yeah. And Phoebe, what's the answer for this?
2/36.
Yeah. Very good. And of course, this is 1/36. Yeah. And I think I already give you like long enough time, and maybe you could yeah, I will give you an extra 1 minute. So of course, maybe Phoebe, can you give us an expression for this? So how to calculate the expected value of x1 plus x2?
Um,
So what times what plus what times what, something like this.
I'm not sure about this one.
I mean, what could be a value for x1 plus x2? What is one value for x1 plus x2?
It's
Any value, just give me one value. You roll two dice, what could be the sum of the two dice?
1 divided by 6.
No, I'm not asking you the probability. What could be a value of the two dice? You roll a three and you roll a three, and that is six, right? So give me another number. So what could be the value for the two dice, right? When they sum up together. I'm not asking the probability. I mean, you already have the probability here, right? You just calculated the probability. So I'm not asking the probability. I'm asking you, you roll a number on one dice and you roll another number on another dice, right? What could be the sum? I mean, the sum can be a lot of things. So what could be one sum? Anything.
Um,
Yeah.
I didn't get it.
I mean, you roll a dice. Say, you roll a dice. What number could you get? Just give me one number. You roll a dice. So which number do you want to get?
1,
Okay, so you roll the dice again. So this time, which number do you want to get?
2,
Okay, so what's the sum?
3.
Yeah, three is it's a value, right? So I'm asking you, what could be a value of x1 plus x2? x1 is just 1, x2 is 2, so the value is 3, right?
Oh, okay.
It's simple, right? And what's the probability of you getting a 3? You just calculated that. What's the probability that?
1 divided by 6.
No.
Oh,
What did you get here?
oh, you mean this one? Okay.
No, and it's not I mean this one. Like you get a so I mean like what's the probability that the sum equals to 3, right? In order for the sum equals to 3, there are only two possible ways, right?
2
One
divided
is
by
yeah,
6.
one is like you roll a 1 and then you roll a 2, and the other is that you roll a 2 and then roll a 1. Do you agree on this?
Yes.
Yeah, and each time, so you roll a 1 and then roll a 2, that is 1 over 36 probability. You roll a 2 and then roll a 1, that is also 1 over 36 probability. So in sum, you have a 2 over 36 probability, right? So the value is 3, and its corresponding probability is just 2 over 36. Did you get this?
Uh,
How could you roll a 3? How could you roll two die and they sum up to 3? How? You roll two dice and they sum up to 3. How? It can only be 1 and 2 or 2 and 1, right?
yes.
So the probability in total is 2 over 36, right?
Yes.
And that means you get a sum of 3. The probability is 2 over 36. Do you agree on that?
Yes.
Yeah. So how to calculate the average value of sum? You just find what could be the value of sum, and use each value time its corresponding probability. Do you get this?
Uh,
I mean, you are trying to calculate the average value of something, right? So if it's appearing really little of times, then you use this value times its like a probability, right? So 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 then what's the other term for you to calculate the expected value? You could also roll two dice and they sum up to 2, right? And what should you use two times? So two should times what? So multiplies what?
1 divided by 36.
Yeah, that's correct. So each value times is a corresponding probability, right? So I mean, this is not something that something too hard to memorize or hard to understand, right? Because you calculate the average value, you just say, okay, this. So it can take the value of 2. It can also take the value of 3, right? But the 2 happens with a very little time, so I like 2 times a very small number. 3 happens a little more, a little bit more frequent, right? So 3 times a slightly larger number, right? To calculate the average value, right? Because 3 happens more often. So we should like 3 times more, a higher weight, right? So each number actually times a weight, right? All the weights sum up to 1. So which number have a higher weight? It depends on which number appears more frequently, right? So 2 times is a probability, which is 1 over 36. And 3 times is a probability, which is 2 over 36. And we are just trying to calculate the average value of sum, right? So we use each value of sum times its corresponding probability. Yeah. So what should 4 times?
3 divided by 36.
Yeah, exactly. And dot dot dot, and we just calculate like this. Okay. I mean this have like so in total we sum up 11 numbers. So we may still need some time to calculate. I will give you 2 more minutes to calculate this and try to give me an answer. Yeah. You see 2 times this, 3 times this, 4 times this, and of course 5 times this, 6 times this, 7 times this. You get the pattern, right? Calculate this and give me a number. I will give you 2 more minutes. Okay, let's get back. So what's the answer for this one? Maybe Emma, did you get an answer for this one?
I think it's 41 over 6.
41 over 6.
Or maybe I calculated wrong because I rushed it.
41 over 6 or over 36?
Wait, my calculator like automatically simplified it.
Don't use a calculator. Try to use your hand. It's a more
Oh,
yeah.
okay.
I mean, it's only 11 numbers, but if you type calculator, you need to type a lot of stuff. Yeah. Maybe, like, I'm not sure. Do you know what's the answer for this?
No, 7.
Very good. So how you really calculate all the stuff and get a 7?
No, I use like EX1 and then plus EX2.
Yeah, you are quite clever. So let's actually calculate them. So yeah, I mean, you are very likely to be correct, and that's what I want you to eventually guess. But let's let's do the calculation to make you to try to find out this through calculations. Yeah. So I mean, it's all divided by 36. So I put divided by 36 at the very end. Yeah. So what's the number here? So it's 2 plus 6 plus it's 4 times 3 is 12, right? 5 times 4 is usually you don't even need a calculator for that, right? So I mean 2, 6, 12, 20, 30, right? 20 plus 30, and this is 42, right? So you see, it's all very good number. It's all integer, no need a calculator. And this is 5 times 8 is 40, right? 42, 40, and then 36, right? And then like 30, and then 22, and then 12, right? And let's calculate them. Get you see, it's all even number, right? So really shouldn't get a 41 out there. Okay, so then what's this? So this is like 8, right? 8, 20, 40, 70. 70 plus 40 is 110, 152. 152 plus 6 is 182 plus 6, right? It's uh, 2, 1, it's like a 2, so 100, sorry, I kind of forgot, I'm not good at English, so I kind of forgot the English number. So 8, 20, 40, 70, 110, 152. 182, yeah, 182 and 218. 218, 218 plus this is 240, right? 240. 240 plus this is 252. Yeah, you see 252 over 36, right? And then you can find that you can verify that 225. So this is equals to 252. 252 over 6 is over 36 is 7, right? Because 36 multiplied 7 is 252. Yeah, so you will eventually find that like ex1 plus ex2 is always equal to ex1 plus ex2. Okay, so since I'm not sure you use this like a clever way of calculating it, so then you need to answer this question. So why is this true? So why do you think this is true? Give an intuition, give an like explanation.
Because EX1 plus x2 is the expected value of like x1 plus x2, and like these you can calculate it by like using 1 plus 2 plus 3 plus 4 plus 5 plus 6, and then you divide it by 6, and like you toss the dice, like I think like 2 times, and that is like it's supposed to be the same like as you like toss one time and you toss like the another time, and you plus like the expectant like number or sum you get.
Okay, yeah, that makes sense, right? So on the left-hand side, we are saying what's the average number of the sum of two dice? I mean, the average number of the sum of two dice is, of course, the average number that you get from one dice plus, right, the average number of the other dice. These two plus together is the average number of the average value of the sum of the two dice, right? The average sum is just the sum of average. Yeah. So it's just like what? So say let me see. So say a hamburger and a Coca-Cola, right? They form a set, right? So it's called set A. And the set A can take on different price for each day, right? So we want to find the average price of set A, right? A hamburger and a Coca-Cola. Yeah. The average price of the set A, you take an average of the price of set A on Monday, then on Tuesday, on Wednesday, on Thursday, right? And you average them. I mean, this is so assume that the price of set A just equals to the price of the hamburger on that day plus the price of a Coca-Cola on that day, right? So the price of the set is of course equals to the price of hamburger plus price of so we assume the price of set is equal the price of hamburger plus the price of Coca-Cola. Then to calculate the average price of set A, we can just calculate the average price of the hamburger and then calculate the average price of the Coca-Cola and sum them up together, right? So this is just like average, right? So when you calculate the average of when you calculate the average of sum, it's equivalent to sum all the average, right? The average on each single items, and you sum it up, right? So it doesn't matter whether you take the sum first and then you average, or you average each item and then you sum it up, right? So these two operations is like no matter what, you get the same result. Right? You always you could give some examples in your real life, and you find that it really makes sense, right? It's also like when you are calculating the weight of something. Say you are calculating the weight of a weight of a basket of stuff, right? I mean, the weight of so say you are calculating the weight of a basket of apples. I mean, the weight of a basket of apples equals to the sum of all the apples plus the weight of the basket, right? So say you have a multiple basket of apples, and in each basket, you have in each basket there are some apples, right? The apples may have different weights, and you are calculating the average sum of weights of all baskets of apples. I mean, it's equivalent to first calculating the average, right? The average of all apples, and then calculating the average of all basket, and then sum them up together, right? It's equivalent to the to first like sum all the basket of apples and then find the average, right? So you can like so like if you have x1 plus x2, you can first calculating the average of x1 and then average of x2 and sum them up. It's equivalent to first sum them up and then calculating the average. This is the main idea. Okay, so for this one, it's a little bit hard to calculate it, and I will give you the answer here. So var of x1 plus var of x2 is equal to var of x1 plus var of x2. Is this always true? Not always true. This will only be true when x1 and x2 are independent. So you see, this is always true, even if x1 is related to x2. And this is not always true. This is only true when x1 and x2 are independent. Yeah, maybe Mark, can you give an intuition or explanation of what does it mean for x1 and x2 to be independent?
Like which one is it? Um oh dear.
I mean, so what does it mean? Like you roll a dice and you roll another dice, right? I say the number on the first dice and the number on the second dice are independent. So what do I mean by that?
Independent.
Like explain independent in your own words.
Is independent like the number on the first dice is not the same as the number on the second dice?
I mean, they could be the
Right.
same, right? I can roll a one. I mean, use common sense. I can roll a one and I can roll a one again, right? So they should of course have some probability to be the same. I mean, if I roll a dice and then I say, okay, the next time you should not roll a number as a thing as a first dice. then that will make it not independent. Why? Because then the value of the second dice will be related to the value of the first dice, right? That make it not independent. So if you are giving a rule saying the first and second cannot be the same, you're trying to interfere, right? You are trying to like you are trying to like exert some rules, right? On the values, you make them related because if you roll a three, then you definitely know that the next dice will not be three because they should not be equal, right? So you are trying to interfere with the number on the two dice. You are trying to use the first dice to influence the second dice, and that makes them not independent. So what does it mean to be independent? It means the number on the first dice should not be related to the number on the second dice. And what does that mean? That means that no matter what you roll on the first dice, on my second dice, I always have 1/6 probability to get 1, 1/6 probability to get 2, 1/6 probability getting 3. Even if I roll 3 on the first dice, that doesn't influence the probability that I get a 3 on my second dice, right? Think of a coin. You toss a head. Does that influence the probability you make a second toss on whether it is a head or tail? No, it doesn't influence it. If you toss the second time, you still have 50% of getting a tail and 50% of getting a head, right? That's called independent. So if you throw a head and then magically you will always get a head, then that is not independent because the first row, the first toss influence the second toss, right? So we say x1 and x2 are independent only when x1, the value of x1, does not influence the value of x2, right? So they have no relation. X1 can be what x1 could be, and x2 will always be what x2 should be, right? Or could be, right? So x2, so before you roll x1, x2 could be anything. And after you roll x1, x2 could still be anything, right? It's not influenced by x1. No matter what you roll on x1, x2 is not related, it's not influenced. It could still get 1, 2, 3, 4, 5, 6, 5 and 6 with equal probability. And we call that independent. Yeah. Okay, maybe Jason, could you give us some example on like two events, right? Right? Any two events, and you think they are independent. Give me some examples. It could be anything, right? It could be whether you eat or not, or whatever. Just give me two events that you think are independent.
Whether it will rain tomorrow and whether I play my computer today.
Yeah, I mean, it's largely like independent because normally whether you play computer today will not influence whether it rains or tomorrow. I mean, but the reverse is not true, right? So by reverse, I mean whether it rains today will probably influence whether you play computer like tomorrow because if it rains today, it will influence like some class. Maybe it rains too hard and your class gets canceled, and then you play computers at home the following day, right? So maybe in the reverse order. So it rains today and it will influence like your behavior tomorrow. I mean that may be true, but whether you play computer today, well, mostly or well, mostly sure that it will not influence whether it rains like tomorrow or not. So we say whether you play computer today or not is independent to whether it rains tomorrow. Yeah, that's a very good example. Maybe Hector, can you give me another example, like two events that are independent? You can use coin, you can use dice, or you can use anything in your life. Yeah, anything. Oh, sorry, I think your mic. Can you repeat? Yeah, I think I didn't get the sound. Maybe it's something on your mic. Yeah. I mean, no worries. We can let Phoebe answer maybe first. Phoebe, can you give us another example on like two events that are independent?
Um, uh,
Anything, anything.
No.
I mean, think of your father and mother, and they say they gave birth to like a girl, right? And that should be independent on their second birth, right? On the on the gender of the second child, right? So the gender of the first child and gender of the second child is largely independent. So even you give birth to a boy or a girl, it doesn't influence whether you give to
For
another.
example, like
Yeah,
rolling the dice,
yeah.
like it is like the possibilities of the top and the down are not influenced by each other.
Actually, top. So what do you mean by top and down? I mean, dice have six faces, right? So what do you mean by top and down?
Like the
I mean, top and down, of course, influence each other because one will always be on the opposite of six, right? I mean, a dice, like one is on the opposite. So,
no, the coin.
coin. Okay. So then what's your like two events?
Like rolling the coin.
Rolling the coin, like two events, right? We need two events.
Yeah.
So what's the event one?
Event one was the top.
So you toss a coin and get a top. And what's the second event in this case?
The pipe.
So I mean, you roll a coin and get a top, and then you roll a coin and get a bottom, right? I mean,
Yeah.
these two events are related because if you get a top, you will not get a bottom. If you get a bottom, you will not get a top, right? I mean, if you just toss a coin one time, right? These two events is not only related, they are perfectly related because if you get a top, you will definitely not get a bottom. If you only roll the coin, toss a coin one times, right? Getting a top and getting a bottom
Oh,
is an example that is perfectly related.
like um,
Yeah. Let me continue to explain on your example. So you actually give a very good example for what we call mutually exclusive. Why? Because getting a top will guarantee that you won't get a head, right? So when you toss a coin, you cannot get a head and a tail at the same time, right? So getting a head will exclude the probability or exclude the case to get a tail. And if you get a tail, you will of course not get a head, right? So these two events, so tossing a coin and get a tail, tossing a coin and get a head, is what we call mutually exclusive. So these two events won't happen at the same time, right? So mutually exclusive events are not independent because they influence each other. One event happens will make the other event not happen. Yeah, but that's a very good example. Yeah, yeah.
weight and height.
Weight and height of what? Like the weight of a person and the height of
A
the.
person.
Yeah. So the weight of a person and the height of a person is largely not independent, right? Because if a person is
Uh,
very high,
okay.
then the weight of the person is, I mean, of course, maybe quite high. I mean, you can say and even if it's a gender and the weight, it is sometimes correlated, right? Because the girl turns to have a like a smaller weight, and a boy tends to have a higher weight. So maybe you can say if for
Like rolling the coin, if you roll two times, they
yeah.
are independent.
Yeah,
Or
yeah, this is a very good example. So if you toss a coin two times, so they are independent. So I mean, tossing a coin. So for the first coin, you can either get a head or a tail, right? That doesn't influence what you get for the second coin. Yeah, tossing two coins are independent. So what you get on the first coin and what you get on the second coin are independent. Yeah, this is a good example. Okay, so I think with these discussions, all of you may now understand what's an independent like event. Yeah. I think that's quite good for us, and maybe let's take a small because we have already give you a lot of time to do calculations, and you may already take some breaks. So let's pause a recording and take a 5 minutes break, and let's be back in 5 minutes.